Hello everyone. So today we are solving a question of JEE ADV 2017. So let's first read the question as it says they're given a circular insulated copper wire loop which is twisted to form two loops of area A and 2A shown in the figure. At the point crossing the wires remain electrically insulated. Okay, so there's no like touching between the wires here. So the entire loop lies in the plane of uniform magnetic field is like B. T equal to 0 loop start rotating with angular velocity omega. Which of the following options are correct? Okay, so let's first redraw this diagram here as given there are a magnetic field in the x like annotation with the symbol x. It means it is inside the page here. Okay, so magnetic field we will denote it like this. Okay, and what is our loop here? It is nothing but it is kind of two loops with area A and 2A. One thing which is very much noticeable here is that suppose it generates an EMF. Okay, first thing let's okay, let me draw all this first. Suppose this is the axis of rotation here. Okay, and it starts moving with this direction. Okay, I mean the what can I say, it's in the anti-clockwise direction as per this axis of rotation. Okay, so how will the flux change in this one? So it will be changing in this direction. It means if suppose EMF is generated in the bigger loop in this direction, so the direction of this will be opposite here. I'll show you here. It is something like this. Okay, if suppose this is the EMF generated in this loop here, cause for this the change in flux is in the opposite direction, and here it will try to oppose this. Okay, so their net EMF will be getting reduced here. I hope this is very much clear from this figure. Like most people presume that they both are same loop moving in the same direction, but no, actually they are loop for which the flux change direction is actually opposite. So d phi by dt is okay, but what EMF is getting generated due to the Lenz law. What Lenz law tries, it tries to oppose it. So d phi by dt will generate EMF to oppose that. The EMF generated will be in the opposite direction here. Okay, so now moving on to our question here. What will be the EMF induced due to in the loop this two-way? Okay, so we can write it at, what is flux, by the way? It is nothing but B dot A. Area is the area vector here. We can write it in the vectorial form. So what is B? B is given as the constant. A is nothing but area of that bigger one, that is 2A. And for that, what is the angle? That B dot A is nothing but BA cos theta. So theta is changing at an direction angle of, I mean at the speed of omega t. So cos omega t, it will be the EMF generated. And what is the EMF generated? It is nothing but the d phi by dt. So if we differentiate it, we will get minus omega times B into 2 omega sine omega t. Okay. And what will be the EMF generated in that smaller loop of area A? Everything will be same, just 2A will be changed to A here. So it will be equal to minus omega BA sine omega t. Okay. As I told you that these are in the opposite direction. So we can denote one as plus and another as the minus one. So what will be the net sum here? So net sum of the EMF will be equal to omega B 2A sine omega t. Okay. Now, our first option says the EMF induced in the loop is proportional to sum of the areas of the loop. No, but this is, sorry, I have accidentally written here 2A. Here it should be A only, because we are subtracting here. So it says that the sum of the area, like EMF should be induced in the loop, it should be proportional to the sum of the area. But this is not the case here, because I have already told you that we have to subtract the fluxes here. Because if the battery EMF generated is in this direction for this loop, so it will have similarly for this loop also. Okay, that's why it will try to, or not, like I made incorrect one. Okay, I can also like show you in this way also. Let's suppose this is same loop. So for this I draw EMF generated in this direction. This is a very much similar loop but only with small area. If I draw the same kind of thing, now you see this plus terminal is opposing its plus terminal. It means the EMF will be getting reduced here. Okay, so using this we can again write it as, so this is the our net EMF generated. the EMF induced in the sum of area. No, it is not equal to sum of area, but it is actually equal to the difference of the area. Hence, our option A is incorrect here. The amplitude of the maximum net induced due to both loop is equal to the amplitude of the maximum wave. So we can see that this is the net, like if I put a magnitude sign here, so this is equal to this in the terms of magnitude here, okay? Because like there is only a difference of the sign here. So it means that the option B is correct here, because they are talking about the magnitude, not of the direction. And the option third says that the net EMF induced due to the both loops is proportional to cos omega t, which is completely false. You can see it is proportional to sin omega t. So our option C is also incorrect. The rate of the change of flux is maximum when the plane of the loops is perpendicular. Okay, the rate of change of flux is nothing but the EMF generated. It is maximum when omega t will be equal to 90 degree. That is this plane will make 90 degree with the magnetic field here. So we can say that when the perpendicular to the plane of the paper, it is correct also, and the current options are B and D here. Thank you everyone.